Okay, 8.5 is about vehicle safety. Now, the best way to try to approach this is to recall our understanding of the second Newton's law, which is F equals ma. And then if you remember from our SUVET, that acceleration itself is also v minus u over time. So what we are saying here is there is a relationship between force and between time, and that relationship is inverse. If time goes down, impact force goes up. We can also say this is the same as rate of change of momentum, because mv minus mu will be final momentum minus the initial momentum. So what we're seeing here is that if you are driving at a particular acceleration and you suddenly decide to bring the car to a stop, the shorter the time it takes you to stop the car, the larger the impact force you're going to receive. And that is the reason for all the safety designs, the seat belt, and all the crumple zones that are all fitted around the car. So this is what this chapter is about. So to look at the contact time as a starting point, consider two masses, M1 and M2. One is moving this way, the other is moving that way. As soon as they hit each other, they collide with each other, we end up with M1 going this way and M2 going that way. So the contact time between them is so minimal. Therefore, if we take one of them, they will receive a very large impact. But that is not the same as impact time. Impact time is after the impact between the two, if one of them then gets stuck into the other, let's say there is a wall, okay, and then there is a moving car, now hits the wall and then pushes the wall in, or the wall as a result of the impact, create a kind of denture or dent within the car. So the car that was originally this way will now look like that, or that was the original shape, we will now have moved this distance. Okay? So which means the wall is having an impact on this time, on this particular car or this object, and the distance that impact is making is that particular distance s. So we need to be able to work out the impact time here, and the only way to do that is to use our SUVET equation, average velocity v plus u over 2 times time is equal to the distance. So if you rearrange that, that becomes 2s over u plus v equals t. And that is your time of impact, because the wall hits the car or the car hits the wall, and then there is an impact, a contact that was delayed between them, which now results into the dent within the car. So in this case, short contact time, they let go of each other. In this case, a longer contact time, which now results to an impact time, and which also results into an impact force. So, and that is how to understand what this is all about. So basically we're saying if we want to work out the impact time, we need to look at the amount of dent or that has been made into one of the objects. So that serves as an introduction to this topic. So we'll look at a worked example in a bit. So let's say the T be 2s over u plus v.